in lesson 5.3, we are adding a new set of identities to our repertoire here. Okay, we already have all those we learned back in 5.1. We didn't really add any in 5.2, but now we're adding some in 5.3. And these are the sum or difference identities. And they look confusing, but once you get to using them and understanding them, you'll get to memorizing them pretty quickly. Okay? I'm going to try and explain them up here, but in all honesty, the easiest way to understand them is to use them, because I don't know how much justice I can do explaining them. But, okay, so sign of a sum or difference. And these can all be used when we're trying to find the sine, cosine, or tangent of some value that we don't know. Okay, these things are typically done without a calculator. These are not a calculator type variety. You'll notice when we get down here, you know, they want an exact value, which is not a calculator value. That comes back to more using our chart. But so a sign of a sum or difference. So the sign of x plus or minus y, and that plus or minus is indicating that there could be a plus sign in there, there could be a minus sign in there. And if that's the case, then it's equal to the sine of x times the cosine of the y, plus or minus the cosine of x times the sine of y. And what I will say on this one, it's plus or minus in both cases. So if the first one is a plus sign, the second one is a plus sign. If the original is subtraction, then in my answer it's subtraction. Okay? And it's really just taking these x and y values right here and plugging them into the formula. That's really what it's doing. It's taking those two values, plugging them into the formula. Cosine works similar. Notice it's cosine of x plus or minus y. Notice this one starts cosine, cosine. So it's cosine x, cosine y. Notice, I don't know, how do you want to say that? It's a minus plus instead of a plus minus. And that is important to notice. Sine x, sine y. The idea here, if it's a plus in the original, since this sign is upside down, it's a minus over here. Or if it's a subtraction in the original problem, it's an addition in your answer. So the fact that it changes from a plus minus sign to a minus plus sign is important to notice. Okay? And then tangent. Tangent's the one we use the least by far. Sine and cosine will come up. I mean, as we move on into other lessons, this sine and cosine business will definitely come up. But tangent, we still need to be familiar with. Tangent of x plus or minus y. On top is tangent of x plus or minus tangent of y. So notice it's plus or minus in both cases, so whatever sign in the original, we use in the answer. On bottom, it's 1, and then notice minus plus tangent x, tangent y. And so in that case, the bottom sign will be opposite. Okay? So it's really just filling in the formulas. As I said, I know they seem confusing, but I promise once you get to using them, you figure out what's going on. Okay? So let's look at example 1 here. Example 1, if I recall, you have quite a bit of this in homework. Should have pulled the book and checked this one. I think there's 2 main sections in homework. One of them is definitely this. So being able to find the exact value of cosine of 15 degrees without using a calculator. Well, first of all, the calculator isn't going to give you an exact value, is it? The calculator is going to give you a big, long, messy decimal answer, so that's not exact. That's an approximate answer. When we have a big, long, messy decimal answer, we have to round. Now, cosine of 15 degrees. Is that on our chart? No. On our chart, we know 30 degrees, 45 degrees, 60 degrees. Technically, if you want to think about it, we know our quadrantal angles, right? We know the 0, 90, 180, 270. We know those angles. But we don't know 15. But we are using sum or difference. So, I need 2 numbers that either add or subtract to be 15 that I do know information about. What do you want to use? Are there angles on our chart that add or subtract to be 15? what?
30.
30 and
45.
45? Can we do 45 minus 30? We could. Technically, is that our only option?
Can we just see that there's the 60 degrees? Those two times that, like, look at the 500.
Well, just think at basic add and subtract. The fact that 60 and 45 also subtract to be 15, don't they? Okay. Now, honestly, you can use either or. I tend to just go with 45 minus 30 because that's the one you guys usually see first. So I'm going to take cosine of 15 degrees, and I'm going to rewrite it. Cosine of 15 degrees is equivalent to cosine of 45 degrees minus 30 degrees. Correct? I've just taken cosine of 15 and rewritten it to say that it's cosine of 45 minus 30. Now, the idea is we have something that looks like our cosine of a sum or a difference, in that 45 degrees is going to be in the x position, and 30 degrees is going to be in the y position. So as we fill in our formula up there, every place we see x in our formula, we're going to replace it with 45. Every place I see y in my formula, I'm going to replace it with 30. So let's go ahead and write it out. When we're using the cosine one in this case, right? So cosine of x plus or minus y is cosine x cosine y. So I'm going to write cosine of 45 degrees times cosine of 30 degrees. Now, because we're in the cosine identity, the original is plus minus. This one's minus plus. So that means since this was a minus sign in my original problem, I'm now going to use a plus sign. And now it's sine x sine y. So sine of 45 degrees times sine of 30 degrees. Now, I want an exact answer, so we're not going to stop here. Do you know something about these values? You're supposed to, right? This is the chart you're supposed to have memorized. What's the cosine of 45 degrees? It is what? Square root of 2 over 2. Times cosine of 30 degrees. What's the cosine of 30 degrees? Square root of 3 over 2. Plus, the sine of 45 degrees is square root of 2 over 2 times sine of 30 degrees is 1/2. Okay? At this point, it's just a cleanup. Do your multiplication and then do our addition. What is square root of 2 over 2 times square root of 3 over 2? Square root of 2 times square root of 3 is going to be square root of 6 over 2 times 2 is 4, plus square root of 2 times 1 is going to be square root of 2 over 2 times 2 is 4. They do have a common denominator. So final answer, when we express this, you will most of the time see them put together as one fraction. Since they both have a common denominator of 4, we can add our numerators. Square root of 6 plus square root of 2 is square root of 6 plus square root of 2 all over 4. Now, curiosity, then why are you grabbing the calculator?
I want to see if it could just be I'm thinking this wrong in my head, but I'm thinking.
Oh, you're trying something different over there.
Okay, yeah, no, that was completely wrong.
Okay, well, what I want to show you guys, quick check. Do you believe that square root of 6 plus square root of 2 all over 4 is the cosine of 15 degrees? That's what's supposed to be, right? So, do the math here. If I go, what is it, square root of 6 plus square root of 2 all over 4. That is equal to that lovely decimal 0.9659, so on and so forth, right? And then, now, I need to be in degrees if I'm going to make this happen correctly. The cosine of 15. Hey, guess what? My answers match up, don't they? Okay, so that's just kind of a little check, you know. I'm not saying you're necessarily going to do that as you go through homework, but there's no proof to you. This is equivalent. Okay, this is equivalent to the cosine of 15 degrees, and this is an exact answer. Because when I plug this into the calculator, it's going to give me the full long same decimal. Questions? Okay. You have a section of homework that is doing just this. Okay? Most of your angles that you're trying to find will be numbers that you can add and subtract 30, 45, or 60, two of those three numbers, and get the answers you're trying in homework. Okay? Occasionally, we might have to wander into the second quadrant and use an angle we know in the second quadrant, and I can help you with that tomorrow. Okay? But this is a big gist of what we're doing here. Now, let's look at example 2. I kind of like example 2. Once you guys get the hang of it, it's kind of fun. Write each of the following expressions as the sine or cosine of an angle. In other words, sine, as we look at A, sine of 22 degrees times cosine of 13 degrees plus cosine of 22 degrees times sine of 13 degrees. That is the sine, cosine, or tangent, if you will, of some angle. What angle? So what do you notice about this sine 22, cosine 13, plus cosine 22, sine 13? What form does it match up with from up above? If it's sine, cosine, plus cosine, sine, does that match up with the sine of a sum or difference? Right? With the idea that, let me grab, if this is sine 22 degrees, cosine 13 degrees, 22 degrees is in the x position, and 13 is in the y position. Again, does it keep matching up? I forgot which one I'm on. Does it keep matching up? Plus cosine of x times sine of y. So this is the what? This fits the form of sine, cosine, plus or minus cosine, sine. So this is the sine of, it's x plus or minus y. Well, x is 22 degrees. Y is 13 degrees. Am I going to add or subtract those? Going to add them? Because this fits the sine mold up there, it's plus or minus, plus or minus. So these signs here will match. And what is 22 plus 13 degrees? 35. Hard math there, isn't it?
Yeah.
Making you do a little bit of work. So that's all we're looking for right there. Take it out of that weird looking mumble jumble and put it into, okay, is it a sine, cosine, or tangent of an angle? Okay, try B. cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. What are your thoughts on this one? If it's cosine cosine plus sine sine, automatically what does that tell you? This is going to be the cosine of some angle, isn't it? So it's going to be the cosine. What are my x and y values? xy, xy. So this is going to be the cosine of pi over 3 plus pi over 4. Except I didn't ask a question, and because of it I goofed. Do you see my goof? What's my goof? The sine. In that, I should have asked, and I didn't. I just wrote plus without even thinking. Okay. We're in the cosine. It's a plus sign to begin with. What do you notice here? If it's plus or minus here, over here it is minus plus, which means my sign changes. Try that again. Pi over 3 minus pi over 4. Not always good to follow your teacher's lead, sorry. Now, Jacob liked the last one because it was 22 plus 13. We gotta go a step farther, guys. What is pi over 3 minus pi over 4? Silly radians always being more difficult. How do we subtract pi over 3 and pi over 4? We need a common denominator. What do 3 and 4 both go into? They're both going to be 12ths. My brain says 3 times what is 12? 3 times 4. So pi times 4 is going to be 4 pi over 12 minus 4 times what is 12, and that's 3. So pi times 3 is 3 pi. What's 4 pi over 12 minus 3 pi over 12? And that's going to be 1 pi over 12. Or in other words, cosine of pi over 12. Are we seeing how this works? You guys are quiet. And you guys are always on the quiet side. It's also the day after spring break. Okay. Sine x, sine 2x minus cosine x, cosine 2x. What can you guys tell me about this next one?
The cosine of some particles.
Okay. It's kind of weird here because it starts with sine, sine, doesn't it? But what do you notice? It has to match up with this right here where cosine and cosine are together and sine are together, aren't they? Okay, so I agree it's got to be the cosine of a sum or a difference because otherwise it has to be sine and cosine mixed up. Would it be helpful if I flip this and rewrite it for you? You know, you kind of have to think it through here. If I flip this and rewrite it, it's negative cosine x, cosine 2x, and then it's plus sine x, sine 2x. So there's a slight trick to this one because when I flip that and I put my cosine first, I now have a negative cosine. Am I allowed a negative cosine in my formula? No, my formula always shows it as positive. And so this is where I would just suggest we factor out a negative. So in order to rewrite this to get it started, I'm going to factor out negative and say it's the negative of cosine x cosine 2x. If I factor out negative, the plus sign in front of sine becomes minus sine x sine 2x. That's my suggestion of the way to do that one. You may have other thoughts. I'm going to carry my minus sign down. As Craig mentioned earlier, this is a cosine, right? And this definitely looks more like a cosine now. So it's going to be the negative of a cosine of, sounds weird to ask this, but what are my x and y values here? What are we doing? We're going to use x and 2x. And I'm not filling in a sign this time. I'm going to make you guys tell me. Are x and 2x added or subtracted?
Added.
Added. This is cosine, so we use the opposite sign of what's in the problem. So an x plus 2x is going to be 3x. So I have the negative of cosine of 3x. Negative cosine 3x is what that would clean up to be. Okay, one more in this section. Is it obvious? I would hope so at this point, right? This one fits into the tangent mold, doesn't it? So we're going to have to say tangent. What are my x and y values? X and y values are going to be the 22 degrees and the 23 degrees. And the big question is going to be, are we adding or subtracting those? Tangent of 22 degrees plus or minus? Plus. Easiest thing I think is it's always going to match the sign on top, right? Assuming we have this normal form set up here. So 22 plus 23 is going to make this the tangent of 45 degrees. Okay. We're going to stop there and leave it as tangent of 45 degrees, although technically we know the tangent of 45 degrees, don't we? Okay. So, yes, it is technically equal to 1, but the original directions were write each of the following expressions as the sine or cosine of an angle, or it should say tangent of an angle. So, okay, are you seeing how these formulas work? Or these identities, I should say. Again, we'll use them in other places. They are definitely helpful. Let's go down and look at the bottom section real quick. Simplify each of the following. Obviously, name of the game here is the sign and difference identities, right? So, sine of x plus pi. X is a variable, so that's just going to kind of carry over in our answer. However, pi is a number, isn't it? And pi is something we know something about. So let's see what we can do here. I'm going to think of those as my quote, x and y values. So how does my sign identity work? Write this out with me. How does sign start? Sine x and cosine pi, because it's sine x cosine y. It's a plus sign in the original problem, so what's that mean in the middle here? It's another plus sign. With our sign identity, it stays the same. This time, we're going to keep x and pi, but we're going to flip-flop our sine cosine. So cosine x times sine of pi. Okay. It's simplified to the following. Clean up anything you can. Sine of x, I don't know anything about because I don't know what x is, so sine of x is going to stay sine of x. What about cosine of pi? Do we know cosine of pi? Where's pi? Pi's over there at 180, yes? So what is the cosine of pi? Cosine of pi is -1 plus cosine of x times sine of pi, and the sine of pi is 0. What do we end up with here? Negative sine x. -1 times sine x is going to be negative sine x. The cosine times 0 is gone. It's just 0. So negative sine x. You got it. So notice in this section we're kind of talking about a lot of our quadrantal angles. Okay, B. Cosine x plus 3 pi over 2. So this time we are talking about our cosine identity, right? Cosine starts off as, are we starting to memorize it? Cosine, cosine. So cosine x, cosine 3 pi over 2. What do we do with the sign for cosine? The sign for cosine, we're going to, this one's the opposite. So instead of plus, I'm going to say minus. Now I'm going to do sine, sine. So sine of x, sine of 3 pi over 2. Well, cosine of x, I don't know. What about cosine of 3 pi over 2? 3 pi over 2 is another one of our quadrantals, isn't it? 0, -1. So cosine of 3 pi over 2 is going to be 0 minus sine x times sine of 3 pi over 2, which is going to be -1. What's my answer end up this time? Not just 1.
No, sine 1.
Sine
No,
of
sine of x.
sine of x.
I don't know why. I saw the 1 and I was like, wait.
I think you got hung up on the fact that it becomes positive there, right? So a minus sine x times a -1 is going to become a positive sine x. Okay, one more. This is tangent of theta minus, that is pi over 4, isn't it? Yes. So, fill in what we can here. Tangent of theta. So on top, I guess we haven't written out the tangent one. On top of the tangent one, it's tangent x plus or minus tangent y. So you're going to keep the same sign that's in the problem. So on top here, I'm going to say tangent of theta minus tangent of pi over 4. On bottom, it always starts off with 1, and then it's minus plus. So you're changing your sign here. So this one's going to be plus, and then it's your two tangents multiplied. So tangent theta times tangent of pi over 4. Clean up what you can. Tangent of theta is tangent of theta minus, what's tangent of pi over 4? 1 over 1 plus tangent of theta stays tangent theta times, what's tangent of pi over 4 again? And that is a 1. The only other real cleanup you can do here is on bottom, that tangent theta times 1 is just tangent theta. So I'm going to write this as tangent theta minus 1. I'm just going to leave it as 1 plus tangent theta on bottom. You could flip that denominator if you want. Okay, your homework is on page 425. One through 22, I believe.